Hello friends, today I shall talk about statistical testing. So we do testing in software development, there is unit test, system test, etc. But today I am going to talk about what do you mean by statistical testing. When we study statistics, we study two parts of it, the estimation theory and the testing theory. So statistical testing is an important part, an important topic. So suppose I considered the height of a person in Kolkata with having age between 30 and 50. Okay, so we call it a random variable x. It takes different values. So I want to test whether the average height of a person in Kolkata with age between 30 and 50 is less than 5 feet or not. So we devise our null hypothesis. We call it h0, average height less than 5 feet, and the alternative hypothesis h1 we design as average height greater than or equal to 5 feet. So now to do the test, we need to test statistics. Okay, the test statistics is average of the sample. So for the testing, we take some data. We take 1,000 people or 10,000 people from Kolkata and with age between 30 and 50, and we record their heights. And the test statistics is average height of the sample. Although I just told average height, it's not that easy. So if x1, x2, xn are the samples, then we consider the average x bar, x1 plus x2 plus x3 plus xn by n, and we calculate and we also calculate the sample variance 1 by n minus 1 summation I equal to 1 to n xi minus x bar whole square. Okay, and we design our test statistics as x bar minus mu root over a square by n, which follows a known distribution Tn minus 1. So it is not that easy, but for the time being, let us consider only the average height of a sample. Okay, now to design our test, we face two types of error. One is type 1 error, that is when we reject our null hypothesis in our test when it is true. Suppose H0 is true but we reject it, so that's an error and we call it type 1 error. And H0 is accepted when it is false, that we call type 2 error. So in designing our test, we try to minimize both the errors, okay, which is not possible when we take down type 1 error, type 2 error goes up, and we lower type 2 error, type 1 error goes up. So that happens. So we define a level for type 1 error, say 5%. We call it size of a test, alpha. So type 1, we consider type 1 error to be, the probability of type 1 error to be less than equal to alpha, and then we minimize the probability of type 2 error. So in our test, we need a critical region. Okay, we need a critical region. When our test statistics, that is the average height of the sample, falls in the critical region, we reject null hypothesis. Null hypothesis. So, how does a critical region look? Say our average height is greater than is found to be greater than 6. So if it is too high, then we reject the null hypothesis. So critical region has two aspects: the form of it and the cutoff point. The 6 is important. How to calculate this 6? This value of the cutoff point that we uh, calculate out, minimizing type 1 error and type 2 error. So that is the critical region. So there is another type of concept which is called p-value. That is probability of critical region when null hypothesis is true. Okay, so when p-value is too small, which is less than 5%, we reject the null hypothesis. When p-value is too small, we reject the null hypothesis. In one of my projects, I studied thousands of samples and calculated the p-values and drew these diagrams. Okay, in 7% case, we see p-value is less than 0.05. Otherwise, the system is stable. So that's the rare picture, the distribution of p-value. Surely this is not bell-shaped, this is not normal. This is an awkward distribution, and I I I drew this figure whenever I was working with a client. Okay, so there are two aspects. You can go by the critical region or you can go by the p-value. P-value is the general case. Let's do some hands-on. So here is some data. Maximum rating of 345 FIDE grandmasters recorded between 2000 and 2017. So there is some 345 data, and I want to test the maximum rating is bigger than 2700 against maximum rating is less than equal to 2700. So in R we just apply the t-test, the t-test, and 2700 is our null hypothesis. We apply it mu equal to 2700 against the alternative that it is less, against the alternative that the rating is less. Okay, so I ran this test against the data, and I found the p-value to be very small, 10 to the power minus 14, very small. So we reject our null hypothesis. In fact, the average of maximum rating comes out to be 2677, and it is statistically significant. The p-value is very small. So we say that our null hypothesis is not true. Rating is less than equal to 2700. Thank you for listening to me. I would stop here. Thank you.